Hello, bSQL developers. Cassidy here. In the last video, I demonstrated how we could use a lifetime keyword to access that version history of the multi-version database. In this tutorial, I'll be showing you how to access a specific version, a specific previous version of the database using bSQL commands. I'll be continuing to use this lift database, and this will show you how to run analytics on previous versions of the system. So in traditional systems like MongoDB, Postgres, SQL Server, and Oracle, in order to access a previous version of the database, we would have had to have taken a snapshot at that point in time. But all this other versions in between here that we forgot to snapshot, all that data is lost, or all those updates are lost. What Blockpoint does and bSQL allows you to do is have more fluid control over what versions you're accessing. So you can really access any version from the beginning of your database all the way up until today. In order to access specific versions of the database, we can use this set transaction query time command that I have written here. So what we're going to do is we're going to start by running this select statement. And if you watched the last video, we went over these lifetime and discontinued words. So what we're doing is we're looking for stations that no longer exist. And the station ID is this Berkeley F7 station. So there we found one. So this Berkeley station no longer exists in the current state of stations. So let's say we want to look at the database at that point in time when it got discontinued. Well, what we can do is we can grab that timestamp and use it in our set transaction query time statement. So I'll go ahead and I'll give that one a run. And that should execute properly, correct. Now we have actually metaphorically rolled back the entire database without, erasing or changing or updating any data or making any copies of any data. We've metaphorically rolled back the entire database so that every single query that we run will operate like it would have operated at this specific timestamp. So this is really powerful because everything that existed in all the Berkeley stations that existed back then, and maybe this departures and arrivals, would also be contained at this time period. So all those relationships still hold. So all those foreign keys, historical reference keys, they still hold given that I rolled back the entire system. So that allows us to do joins over data that no longer exists. So this right here is just to illustrate that I can operate now like the database was at that specific point in time. So I'm looking for rides that departed from the Berkeley F7 station and arrived somewhere else in Berkeley. And I'm joining it here, here, and here. So I'm going to give this a run. And this is operating just like it would have operated at that timestamp. And we get a nice result. So you can really use these timestamps, this set transaction query time, to go back and look to basically pull that test data set that you were going to use and run analytics on it. It allows you to go back and check for audit trails or check, what the current state was at that point. And that's super powerful because it completely omits the need for taking database snapshots, which can be hectic and can give you redundant copies of data. It can increase the amount of IOs, the amount of read and writes that you're doing on the database. It can really bog it down if you have a lot of those snapshots. So here, snapshotting is really built into the system, and it's easily accessible through a single command that is not impacted. It's not heavily impacted by, the multi-version data or the data that you're not querying in this case. And it's really simple and straightforward and easy to use. So thanks for joining me, and I'll see you in my next video.